Okay, folks, here we go. This is going to correspond to assignment number 20, estimating population proportion. We're going to have two types of questions that we'll talk about when we go further into this. And one of them is to develop what's called a confidence interval, and we'll have a process for determining that, and we'll discuss all of the ins and outs about that. And then we also potentially could perhaps determine a sample size. So those are the two types of questions we have. You have the notes that were uploaded to you and the examples, and so hopefully this will all come together for us. All right, so anyway, sorry I had to get something ready here. So to me, the key thing is to find the appropriate formula for the question. That's what's really important. So here's the idea. Example number 1. A survey of 80 families showed that 36 of those 80 families owned a gun. So what I would hope you'd realize would be that you could change that into a percentage, couldn't you? Or another fancy word for that is proportion. So 36 out of 80, which we could go ahead and actually divide out, and 36 divided by 80, I didn't get that in there right. 36 divided by 80 is 0.45. So the point is 45% of the families surveyed own a gun. All right? Now, those 80 families would be a sample, wouldn't they? So what I want to remind you would be, this goes back to this picture we've had up here many times. That would be what we call a point estimate. Because, let me try to pull this all together again. The ultimate goal would be to estimate what percentage of all families own a gun. That's called a population parameter. Okay? Estimated. We're never going to know for sure what percentage of all families own a gun. But we have a good starting point, the percentage in our sample. So we took that sample of 80 families, and we found that 45% of those families in our sample own a gun. And if you're going to estimate what it would be for all families, then that would be a good number to start with. So the point is that 45% would be called a point estimate. It's a number that we use to begin our estimation for the percentage of all families that own a gun. So, samples and populations. Now, the mean of a sample is called X bar. The mean of a population is called mu. That's not the type of parameter that we're estimating in this question. We're estimating a proportion, otherwise known as a percentage. So the question I have for you would be, does anybody remember the symbol we give for a percentage, a proportion that was obtained from a sample, right? Because this is the percentage of 80 families. That's a sample. What's the symbol for a percentage obtained from a sample? Anybody remember? Oh yeah! It was called p hat, right? That's right, p hat. Remember that? Okay. That's the percentage of families in our sample that own a gun. It's called p hat. Again, I assure you that a person I know gave this to me and they said it came from the supply closet. I sure hope that's the case. Anyway, the point is we're using that percentage from our sample to estimate what that percentage would be for all families. And if you were going to begin to estimate the percentage of all families, called P, that owns a gun, your population parameter, 45% would be a good point to start with, right? So that's our starting point, our point estimate. Variance, that's also there, but again, irrelevant to this particular question. So this slide's been up here multiple times and we've talked about it together. So let's move back to the question. So do you just say, well, I think the percentage of all families that own a gun is 45%, good enough for me? No, what we do is we build what's called a confidence interval. Okay, so this question says, what's the 95% confidence interval for the proportion of all families, the true proportion, the percentage of all that own a gun? We'll talk about the 95% and all that moving on. Okay, so, well, this, in my opinion, would be the easier type of question because, here we go, back in your notes, if you want to build a confidence interval for a proportion, the flow chart is pretty boring because it's just that formula right there. And so if you want to build a confidence interval for a proportion, and I'm a big believer, and this is why you'll find in the homework that there are boxes for you to write down what's the appropriate formula for the question that you are currently working on, all right? And we're going to pick apart these different things as we move on. So p hat plus or minus, I've discovered it makes sense to crunch numbers first, and then we can begin to interpret them. All right, so let's start with this. We know that the p hat here, let's start plugging numbers in. P hat is 0.45, 45% of the families in our survey that own a gun. Let's skip that Z-score for a minute, save it for dessert. Okay, here we go, p hat, 0.45. Okay, now I hope you remember that Q, P and Q are complements, aren't they? In other words, this would be the percentage that do not own a gun. Wouldn't that be 1 minus the 45%? 55% do not. You hopefully remember how P and Q relate to each other. So Q hat is 55%. That's the percentage in our sample that did not own a gun. And then the N would be the 80 families that are surveyed. Bang. All right, so that all should look familiar to us. Now, we said we would save that Z-score for dessert. Let's get after it. And by the way, this is part A of this question. So, here's how it works. Z should make you think standard normal bell curve 0 in the middle, shouldn't it? I hope so. This marker's getting a little bit faint, so I'm trying to get one that would be a little bit darker for us. Now, that Z-score is going to be related to the desired level of confidence that we wish to use. In part A, it says 95%. So, I'm going to put that 95% up here, 0.95, and here's the idea. In part A, we essentially, just trying to keep it simple, we want to capture the middle 95% of the bell curve. All right, now we've looked at this kind of question before. So if you recall, we say, hey, if you want the middle 95%, and the bell curve is symmetrical, by the way, so wouldn't you put a certain portion of that over on the top side, on the upper half, and wouldn't you put a certain portion of it on the lower half? And since it's symmetrical, wouldn't it make sense to cut it in half? So this would be like those questions we did where we said, find the Z-scores that encompass the middle 95% of the bell curve. So what we did back then, and what we're going to do today, is we're going to take that 0.95 divided by 2. We're going to put half of it on each side, and I think that would be 4750. That's half of 95, isn't it? 0.95 divided by 2. Alpha over 2. Find the Z-scores that correspond to alpha over 2. All right, technically the 0.95 is not really the alpha, but don't worry about it. That's how it connects. You're taking your significance, your confidence level, pardon me, and cutting it in half. What did that do? It made 2 middle slivers, didn't it? 4750. And the hope would be you look at that now and go, well, cool, that's a couple middle slivers. Table love middle sliver. Table love middle sliver. This is one of the major reasons that Mr. Statistical Anomaly likes that middle sliver table. It works perfectly for these types of questions because when you do confidence intervals, you end up with middle slivers. All right, so this is ready-made for that. So the point would be, once we cut that 95% in half, table time, we've got middle slivers of 4750. All right, and this is our lucky day because I think 4750, if I remember, that is in the body of the table perfectly. Look at the one in front of you or memorize it, but 4750 lines up with 1.96. And so 1.96 on the plus side and 1.96 on the negative side. There you go. Now you might say, which one are we supposed to put into the formula? Both, plus or minus. Plus or minus. See, this takes care of both of them, plus and minus. 1.96 standard deviations above the mean, plus 1.96 standard deviations below the mean, minus. Okay, so at this juncture, it's total snob here, but it's just arithmetic essentially. So here's what we would throw out there. We'll say, we got our 45%, which is our starting point, plus or minus, give or take. Okay, let's do the math, and I think you'll see this totally now. If you follow the order of operations, crunch that out, multiply these, divide by 80, then take the square root, then multiply by 1.96. It's an assumed skill that you brought to the class when you enrolled that you can crunch this out. So I'm very hopeful that this is going to come out right. And if not, I'm not sure what to say. But if you do the order of operations here, this is roughly 0.1090. Let's start to interpret things here. When you create a confidence interval, what you're essentially doing is you're saying, I'm going to take the percentage from my sample and start with that, and then I'm going to give myself some margin of error. That's what that number that follows the plus or minus represents. So the general format here is your point estimate plus or minus error, give or take. All right? So if I were to ask you what percentage of all families own a gun, you'd start with 45%, because that's what you got when you surveyed 80 families. And you go, 45%, give or take, plus or minus 10.9%. I hope that made sense. So, there you are, plus or minus, above and below. Now, to purely make this into a confidence interval, and we're going to talk about this a lot, this is going to be a 95% confidence interval. Your choice of confidence is arbitrary, all right? But the idea here would be this: let's make it into what they call in algebra an interval. And so the point would be that when you learned intervals in college algebra, you always said smaller number, comma, larger number. So I hope it would stand to reason that to get the smaller number, you would subtract. In other words, this will be the low end of our estimate. If I was going to estimate the percentage of all families that own a gun, I would say, well, on the low end, minus, we'll take that 0.45 minus 0.1090, and that will give us 0.341, about 34%, let's call it. So if I said, hey, estimate for me the percentage of all families that own a gun, you'd say, well, on the low end of my estimate, this is like a mechanic giving you an estimate of what it's going to cost to fix your car. They'll say, well, I think it's going to cost somewhere between here and here, and this would be your lower end of your estimate. And then the upper end would be to do the plus. So when you add, you get 0.559, roughly 56%, and that would be considered a 95% confidence interval. I don't know why I wrote this over here so far. So this would be the answer to part A. We'll talk extensively about how important it is to identify what your level of confidence was, 95%. That's a 95% confidence interval. Now, let's interpret that quickly. And I hope I say this right. If you did this process a large number of times, sample and perform this process, 95% of the time, the actual percentage of families that own a gun would indeed fall within your interval. All right, so 95% of the time that we do this process, our interval will actually contain that true percentage of all families that own a gun. But there's still a 5% chance that it won't. That's my take on how to say that. All right, so to emphasize the importance of that and the fact that it's arbitrary, let's just talk about part B while we're at it. So now let's find a 98% confidence interval. Okay, well the idea there would be that that's going to change this, which changes this. What does that impact? The Z-score that we plug into that formula. So in that example, now we're looking at part B. Again, hit pause in between each time if you need to. I should have warned you of that. But if we want to find a 98% confidence interval, it's really just going to change one number in the calculation, the z-score. So 98% cut in half, 0.98 over 2. Sorry if you can't see those numbers. I wish, I know we're here, but we're not here, you know what I mean. But anyway, that would give you 2 middle slivers of 49%. And I'll put those extra zeros on the end of that. 4,900 basically. That's half of 98%. You're putting half on each side of the bell curve. And so then you go to the table and you look that one up, don't you? And I will point out again, those are middle slivers. They're perfect. This table loves middle slivers. So 49%, 0.49. And look, I'm going to do what we've talked about. I guess I should do it one more time on this one. But in the body of the table, that 49% that we're looking for, middle sliver, if you look in the body of this table, and I walked away and I forgot them already, 4901 and 4898. So as we've said many times, in a case like this, 4898, this is 8 away. It's only 1 away. We'll go with that one. The closer, if there is a closer, if it's a tie, you average them. We've talked about that. So 4901 lines up with 2.33. 2.33 plus or minus. So going back to this setup, that changes our z-score. This time we have to go 2.33 standard deviations. If you think about it, if you want to increase your level of confidence, you have to have a wider net, right? So anyway, that changes that number, which changes this number, which changes everything else. And it's also going to be important then, when we give our answer on this one, that we tell the viewer that this time it's 98% confidence, right? You change the level of confidence and you change the math a lot. So anyway, okay, your margin of error, 0.45 times 0.55 equals, divided by 80, equals, square root of, equals, times 2.33. And this time the margin of error is 0.1296, roughly 13%, let's say. And, and then just like the previous one, and I didn't do a good job of spacing this out, look at all that, but you get the lower end of your estimate by subtracting the margin of error from the 45%. 45 minus that number is here, and 45% plus that number is here. All right? And there again, off the top of my head, that ends up being lower end of it, 0.3204. In math, when you write an interval, it's always the smaller number, which would always be by doing minus. So about 32% on the lower end, and then when you do the plus, you get 0.5796. And that would be the answer to that part of the question. So again, in your materials, I believe you're going to find, after each of these examples, the answers. So in part A, 95% confidence here, part B, 98 here. So again, the level of confidence will impact that z-score that we stick into that beautiful formula. All right. All right. So anyway, Mr. Soda Pop really misses you guys. I'm really hoping that this is working, and keep the faith. Here we go.